Hey, what's going on, guys? This is Matt, and today I have another exciting video for you. We are doing another DIY build, something to track fermentation activity and also fermentation temperature. I'm going to be showcasing some software that I found online called iBlopper, so there's going to be more in detail later in the video on that. I'm going to go over how to build the hardware and then also how to install the software. I also expanded upon this software. I actually integrated this in Home Assistant. If you're unfamiliar with Home Assistant, it's something really used for home automation where we can set up alerts and notifications to go out. I'm also going to show how to tie in the iBlopper software with Home Assistant and to pretty much make a DIY Inkbird for only $10. So also stay tuned for that at the end of the video. Anyway, guys, we're gonna go ahead and jump right into the build and where I can talk about iBlopper first, then we're gonna go into building the hardware. Now to jump into iBlopper, this is an activity fermentation logger to be attached to your airlock. It works by detecting tiny vibrations when a bubble is released, reporting blops per minute or BPM. This creates an SG estimate, and the temperature is also reported into the cloud, which we'll go into later in the video. So this works with beer, wine, and mead. So this is a DIY project to source components, and you can build this yourself. The person managing this also provides some software where you can download and flash the hardware as well when we're done building it. So I'm just going to kind of briefly walk through the site. This link will be right into the description below the video. So it has kind of a brief description of what iBlopper is. It has more details about what iBlopper is, and then it goes to how to build it. There's a lot of videos he provides on how to set up the iBlopper as well. This goes into the iBlopper cloud, which there's a link on the top right hand corner of the site as well. But as you can see, the cloud reports your temperature, your bubbles per minute, and then the sum of the bubbles, and then the SG estimate as well, based on how many bubbles is reporting. He also provides some data behind how this works, so feel free to check that out as well. So we can go ahead and go to the how to build. And he has two designs here, one with a node MCU. So there's this option here, and then he has another build that has the D1 Mini. This is the build that I chose to use. So feel free to follow the installation guide right on this site. I will say I did make one change where the ground for the temperature probe says to connect to D5. I actually had to connect this to ground. I'm going to show you how I built this now. I'm going to kind of walk through step by step on how I solder this and put this all together. So hopefully it's easy to follow. For materials, all the links will be in the description of the video. You'll need an MPU 6050. This is a gyroscope. You'll need a D1 Mini and a USB cable for power. If you also want to monitor temperature and build a DIY Inkbird, you'll also need the temperature probe and a resistor. The soldering iron is also recommended. First thing we're going to do is snip back the connectors so they don't protrude from the board once we solder them. So just try to mirror the sides of the smaller side of the connectors. Next, we can attach the connector to the D1 Mini. The best way to hold this in place was to just use the weight of the D1 Mini to hold the connectors in place. You want to set this on the side of the ground on the D1 Mini. Next, we can get to soldering. So just put some solder on all 4 spots. If you've never soldered before, it's really easy to learn. Just check out some tutorials online if you'd like to learn how. After the connectors are soldered to the D1 Mini, we can flip it over and set the MPU 6050 on the connectors. Please take note of the direction we are connecting the gyroscope. We want to try to solder this gyroscope parallel to the D1 Mini. I found that the USB port actually did a good job holding this parallel. Lastly, we get this soldered, so this is what it should look like from this point. So check your soldering points to make sure the pools don't touch each other, and you can also make sure the boards are parallel to each other. If you're going to add the temperature probe, just go ahead and strip the wires. The easiest way I found to do this was to just score the cable and roll it with your finger to cut the cable, and you can use your teeth to lightly pull the sheath off the cable. If you cut it too deep, you can just try again. Now you want to just set the yellow cable to the D7, the red cable to the 3 volt, and set the resistor between these 2 connectors. Next, you can attach the black cable to the ground on the other side of the D1 Mini. You can just heat up the blob of solder that's already there when we attach the gyroscope and push the cable in the solder. To really wrap up the build, the last thing we have to do is really just figure out a way to keep water off of this device when we attach it to the airlock. There's one of two ways you can do this. The first way, and this is the easy way, is you just take an empty water balloon and just wrap it around the sensor. So that way when you attach it and if it gets wet, it will kind of keep the electric components safe. The cleanest way to do it is you can actually 3D print a wire junction box, which I'll put this Thingiverse link in the description below. If you have a 3D printer, I would probably go this route just because it's cleaner, and also when you rubber band the components to the airlock, you won't have to worry about damaging the components. If you don't have a 3D printer though, just don't worry about it. This is really just a nice to have, it's not needed. Okay, so once it's all built, we can go back to the iBlopper website, and then he has some instructions on how to flash the hardware. The first thing you're going to have to do is you're going to have to install some drivers. So when you plug in this device to your computer is probably not going to recognize the hardware until you install some drivers. So make sure to follow this link and download the drivers and get those installed, and then plug in your board to your computer so your computer will detect it. Next, you can install this ESP Home Flasher. This is the ESP Home Flasher. It's all this is designed to do is to take a bin file and flash it onto the hardware. When you open up the ESP Home, check the serial ports up here and choose the serial port that the computer is recognizing the hardware as. If you have multiple COM ports listed here and you're not sure which one is your board, unplug your hardware from the machine, refresh it, and then plug it back in and refresh it, and whatever one was added, you'll know that's your D1 Mini or your ESP device. So once you have it selected, you can go ahead and download the bin that you need. If you look down here, he has some stable versions and some beta versions. I would recommend just the most stable version for the D1 Mini or the Node MCU. You're gonna have to select that as the firmware. So if you browse, select this file and then flash ESP. That it will be flashed. It doesn't take long. Once this is flashed, you're going to have a certain amount of time to set this up. So what's going to happen is once this is flashed and ready to go, is that your actual device will kind of turn into an access point. So you need to connect to the device so you can set up some credentials. If you go on your phone and then you search for a wireless network, you'll see that the access point will actually show up as a wireless network, and it'll have a set of numbers here as well. So if you click on the iBlopper Connect with the set of numbers, your phone will automatically take you to this manager where you can configure your Wi-Fi. So you're going to want to put your Wi-Fi creds, so your SSID, so the name of your network, and then your network password, and you can save that. You're also going to want to make note of the number that's directly behind the iBlopper Connect, because that is going to be your username to log into the cloud. Lastly, once that is all configured, you can register and log in. So if you go to the iBlopper Cloud, which is right up here in the top right hand corner of iBlopper Cloud, you can click that, put in the number as your username. This will be, again, the set of numbers that's directly behind the iBlopper hardware when you connect to it as an access point. And then you want to create a password and you can submit. And once that's created, you can log in. So I want to quickly go over the cloud and show you a few options and how to log a brew. So when you log in, this is pretty much what it should look like. It should say no active brew currently. And then on the bottom here, it will list the old brews that it recorded down here. So if you wanted to view the archive of what you've done previously, you can check that out as well. So if you go to settings first, we can change a few things here. You can change this to Celsius or Fahrenheit here. You can set your time from UTC, so your time zone. You can choose to use your gravity estimate, which I would recommend leaving it as a yes. The cycle's time to run in minutes. It's not defaulted to 1, standard is 6 minutes. But I changed it to 1 because I'm actually using this device as an Inkbird. So I want to send that data as often as I can. If you're not planning on using this device as an Inkbird, which I'll set up at the end of this video, if you're just choosing to use this just for the estimations, you can leave this as 6 minutes. For the sensitivity of the gyroscope, you can just leave this as 4, and then you can hit update. Next, we can go ahead and log a brew. So let's assume that you've brewed and you're ready to go. You've set up your S airlock and you've rubber banded this device directly to your airlock. There's a few pieces of information where you can start the logging process, so you can name your beer. So I just actually finished a brew day, so we can just call this best bitter. You need to select your brew size in liters. So how many liters of wort do you have in your fermenter? So this I have 20.5 liters. Next, you want to record your original gravity that you measured right after brew day. So mine was 1046. Now for the polynomial, right up here, it kind of goes with the description of what this means. This may change from brew to brew. So this is something you may have to update depending on if you want an accurate final gravity estimate. For me, I just kind of did a generic, what I think most brew days would be like, and if it's off by a few points, it's not a big deal for me. So the polynomial is decided by headspace percentage multiplied by this value multiplied by fermenter scaling factor. So if you are using a metal fermenter, you're going to probably want to set this value as 1.25 to 1.33. If you're using a plastic fermenter like I am, like a bucket, you can just leave this as 1.0, and then you want to just put in the headspace here. So for example, if you have 30% headspace to your fermenter, that's empty, and you're using a plastic bucket or a plastic fermenter, this is your polynomial right here. That kind of goes to what this is. And again, the more accurate you can get this value, the more accurate your final gravity reading is going to be. So once you're ready to go, you can start logging. And then all the data from your device will then be sent directly to the cloud. So you can always view or edit the current beer. So if we click view, since we just set this up, it has your information up here, but there's not really any data recorded yet. But you're going to have the temperature, you're going to have the bubbles per minute, you'll have the sum of the bubbles, and then you'll have the standard gravity estimate as well. So as you get more bubbles, this estimate should go down. I've done 2 test brews. I'm actually on my 3rd test brew right now, and it seems to be around 5 points off, but there are ways where you can make this a little bit more accurate. So if you go back to your home page here, you can hit edit, and you can actually take a midterm gravity reading, and it will help update the data that's being sent here to give you a more accurate final gravity number. I don't really mess around with that since it's kind of difficult to take midterm gravity readings, so I just kind of let this go and hopefully it's close enough. But I always end up taking a final gravity reading anyway with the hydrometer. So the final gravity reading to me is kind of a nice to have, but it's not super important. For me, the great thing about this tool is really twofold. The first is to know when active fermentation is completed, so when the bubbles per minute reaches 0. And then also the temperature logging, so we can hook this up to other components like making our own Inkbird temperature controller. At this point, if you don't feel like hooking this up to Home Assistant, if you don't want to set up any alerts to your phone, if you're not interested in building your own Inkbird temperature controller, at this point you can stop here. You can just use iBlopper through the iBlopper cloud. If you're interested in knowing how to connect this to Home Assistant and to build your own Inkbird temperature controller, I'm going to jump into that right now. Okay, so now to jump into Home Assistant. You're gonna have to first install Home Assistant if this is something that you're interested in. I'm not gonna go into a detailed explanation on how to install Home Assistant because I actually have a video already on my YouTube channel where I walk through how to install Home Assistant and configure it as well. That is in my DIY keg monitoring video, so I'm gonna go ahead and post a link in the video now, and then also in the description, I'm gonna have a timestamp of where I talk about the Home Assistant installation. You're also going to want to set up Studio Code Server, and that's on the left hand side here. And again, in that video, I walk through how to set up Studio Code Server as well. So now I'm assuming that you already have Home Assistant installed and Studio Code Server set up, and you have iBlopper set up as well, and you're all set to go on that front. Before we get too deep into this as well, I want to shout out and thank Klaus. He is the guy who wrote all the software for iBlopper. I reached out to him personally and asked we could set up some sort of REST API for iBlopper where I can get iBlopper data directly from his tool. And he was nice enough to set up a REST API just for me, which is great. And he now actually has documentation about the REST API. If you go to the iBlopper cloud, you log in, and then you go to settings. There's now an advanced settings, REST API, and temperature controller support. So if you click advanced settings, he actually has some information over here about the REST API, where he's going to show you how to set up the RESTful commands, the get commands where you can get this data from, and then you can parse that data in Home Assistant. So I just want to thank Klaus for helping me out with this project and allowing me to use his product in Home Assistant, as this has really become very useful to me. So now we can get started with how to grab the data from iBlopper, and first of all, just be able to put it on the front page of Home Assistant. You're going to do this first by creating an authentication token, and you can really name this anything. And just for the example, I just put anything here as my token, and you're going to need to do this before we do anything in Home Assistant. So make sure to log into Home Assistant, go to settings, go to advanced, and in here just type in whatever you'd like for the authentication token, just make it unique. And then once you hit update, then there's your token for authentication. Once you have your token created, you can go into the Studio Code server. And I actually have some few snippets of code here, but I'm going to walk through all of this, and it's really not that complicated. But I do have this code snippet down in the information section below. There's going to be a Google Doc where you could just cut and paste this code directly right into your configurations.yaml file. There's a few pieces of information you're going to have to update, obviously, because this is my device ID and my token. But as you can see, it's a few things you just need to change. So for the code, there's just 4 REST commands here. So you can see there's 1, 2, 3, 4, and they all do something different. So if you just walk through one, they're all set up fairly similarly. So you're going to name the REST command. So I have for each of these iBlopper, and then I have bubbles per minute, temperature, sum, and gravity. Next, we need to set up the resource, and this is the URL that we're going to use to grab this data. So you're just going to put in, copy and paste this URL in there, except for your device ID. You're obviously going to change this to your own device ID. If you can't remember what this is just the username you use to log into iBlopper Cloud. And then token, obviously, is you're going to replace this with whatever token you added. So again, I just added anything. Next, we're going to add a method, and this is a GET request because we're getting data from this resource. And then next, we need to add a value template. And what a value template is this API. When you perform a GET request on this API, it returns a ton of data, and we're only interested in a few pieces of data. So this is what the value template is we're actually parsing this GET request, this response for this JSON value BPM. So this is the bubbles per minute. And then we're taking that value and rounding it by 2 to make it a little bit more presentable for us. So that's all we're doing is we're just JSON value.bpm. And again, for all 4, there's going to be .temp, .sums_blobs, and then .gravity here. And then some of these things we're running different logic on it. So we had to convert, he's using Celsius. So this is just to convert the Celsius value that he's returning and converting it into Fahrenheit. If you want to keep the Celsius, you can delete just this section here, and then you can just round it by 2, just like we did up here. Just remove the parentheses because you won't need those. The only other thing we need to do is force update true. I don't necessarily know if you need to add this line, but I added it to mine. So I would just suggest, just for the sake of everything working correctly, is that you also add this line as well. But that really covers the coding part of this. Once we have this set up, we're gonna have to restart Home Assistant. So go ahead and go into your configurations, settings, you can check configuration and then restart. Once you restart it and Home Assistant comes back up, then this code should be published in Home Assistant. So now you can start playing with these values.
So the first thing we're going to want to do is we're going to want to add these values to your home screen so you can see the values directly from your iBlopper. That way you don't have to log into iBlopper Cloud every single time you want to view this data. So if you go into the top right, you can go to Edit Dashboard, add a card, and then you can use really, there's a few things you can use here, but I believe I'm just using entities. So you can go ahead and choose entities. You can name this whatever you'd like. So we can just say iBlopper data. And then for here, we can just choose the entities you want to choose. So as you might remember, we named all 4 of those REST commands with something. So if we just search for iBlopper, there's going to see the BPM, the gravity, the sum, and the temp. Go ahead and add all of these 4 entities and hit save. Once you hit save, then you should have this data. Now this data updates every minute because if we go into settings, the cycles time to run is 1 minute. So this data right here is going to be updating every minute because that's what we set it here. So if this is still 6 minutes like it is, then you won't see this data updating until every 6 minutes. That really concludes getting the data from iBlopper and getting it processed in Home Assistant so it can be displayed. Next, we're going to set up an alert. So when the bubbles per minute reaches 0 for a certain amount of time, we're actually going to receive a text saying fermentation is done, and it's actually going to give us the estimated gravity texted right to our phone. So we can do this by going into configurations, automations, and you can create an automation here. So right here, you can hit add automation. I already created mine, so I'm just going to go ahead and open mine, and you can just really copy what I have here. So for the name, we're going to name this whatever you'd like. I just have firm completed. We're going to need to set up a trigger, so something to trigger the automation, and our trigger is really looking at that iBlopper_BPM. And what we're looking for is the numeric state of this entity. And when it drops below 1 BPM for 10 minutes, it's going to trigger this. And then next we need to set up an action, because once this is triggered, there needs to be some sort of action here. In order to see the service where you're going to have your iPhone, you're going to have to install Home Assistant on your iPhone or your phone in general. So make sure to log into your phone, go into the App Store, download Home Assistant, and log in. Once that is completed, you'll now have a service here. I'm also going to copy and paste this directly into that Google Doc as well, so you can have the YAML to update here. You're obviously just going to have to update this right here because that's my phone, not your phone. And then you can really pass it just this data. So this is saying estimate in text, and then it's just grabbing the state of iBlopper gravity and then putting that state right in here, and then FG. So it'll say, text me fermentation completed, estimate is, I don't know, 10:06 FG. And that's when iBlopper is less than 1 for 10 minutes. So it's kind of a cool little alarm to set up so you know when fermentation is actually done and ready to go. The one thing you should be aware of is obviously you might get some false triggers here in the beginning of fermentation when there isn't any activity going. So every now and then, maybe for the first day after you put your beer in the fermenter, you might get a few texts, but hopefully that doesn't bother you too much. If it does, you can disable this and re-enable it, whatever you'd like to do. Okay, so next we're going to set up an Inkbird. And what if you're not familiar with Inkbird, Inkbird is a temperature monitoring piece of hardware where you can plug in like a heat mat on the heat side or a fridge to the cool side, and there's a probe. It's really just a temperature controller. So we can do a DIY temperature controller in Home Assistant with a smart switch. Now for the smart switch, I recommend this Sonoff S31. This is the one I'm using, so go ahead and pick up this smart switch. There's obviously a lot of smart switches, but you have to be careful because some of these smart switches require custom firmware where you need to actually crack these open and flash custom firmware on the smart switch to get them to work with Home Assistant. With Sonoff, you do not need to do that. We now need to connect the smart switch to Home Assistant. Now, I have to say that this was probably the most complicated thing out of this whole process, but I can't necessarily walk you through it because, again, I don't want to make this video 1 hour long. Check the description out below. I'm going to post a video down there where you can follow. If you just Google around, there's lots of videos on how to set up sawn-off smart switches with Home Assistant. But essentially, we need to get to the point where if you go into developer tools, you can now search for switch. And this is what you want. So whenever you're at this point, we can continue. But the switch needs to be loaded into Home Assistant where there's a designated entity in here where it reads the state. So right now, the switch is loaded in Home Assistant and it's off right now. So I'm going to assume that the switch is already installed and ready to go, and you can search the entity here and it's working properly. So the first thing we're going to want to do is we're going to want to create an input number box on our home screen where you can enter in the desired temperature that you want the Inkbird to hold, or the DIY Inkbird to hold. So go ahead and check the description below. I'm going to have a Google Docs there where you'll have the input number. You can have and then just copy and paste this directly right into your configurations.yaml file. You don't really need to change anything in here. It's pretty generic. Once you have this entered in, again, we have to restart Home Assistant before it will read. So go to settings, check configurations, restart. Once it comes back up, we can now go to overview, and you should see this desired temperature with a value here. So this is important because, again, this is what we're using to set our Inkbird to. So once this is configured and you have the iBlopper data being read properly, we can now set up some automation to flick the smart switch on and off. So if we go into configurations, automations, and we're going to want to add two here. So I have an Inkbird heat and an Inkbird heat off. So we're going to, first of all, we can set up the Inkbird heat. Go ahead to add automations, and then I'm going to just open mine so you can see what this looks like. So again, the name is Inkbird heat. So this is going to be the automation to turn on the smart switch, which will then turn on whatever you're using to heat up. For the triggers, we're just going to set up a time pattern. All this time pattern is it's going to run this automation every minute. Next, we're going to set up a condition. So what conditions are is they're optionals, but it will prevent the automation from running unless the conditions are satisfied. So this is running every minute, but we need to check the value of the iBlopper value against the number input, the input we have in that box one we just added, and compare them to make sure that do we actually want to turn on the heat mat. Just because it's running every minute doesn't mean that the conditions are satisfied to turn on the heat, right? So we're going to go into template, and you're going to copy and paste this directly, again, from the Google Doc right into your value. The only things you may have to change here is this line right here. If you named it something different, if you copied and pasted it all the same, then you won't have to change this value. Similarly to box one, again, if you copied and pasted it for that input box, then you won't have to change this either. Really quickly, just to understand what this is doing, you're taking the state of the iBlopper temperature, you're converting that into an integer. You're saying it has to be less than the input number of the box one. So whatever value you enter in there, you're converting that into an integer, and then you're subtracting 1 from it. We're also adding another condition. Go ahead and hit add condition. And what this is going to do is you can create a state. So we're choosing the switch here. So we're going to choose that switch entity. So go ahead and type in switch and then choose the switch here. It might be named differently on your end. This is what is named on mine. Again, depending on the video you watch, this might show up a little bit differently. And then it says the switch has to be off for this to work as well. So not only does the value of the iBlopper temp have to be -1 of the input number box, but the switch also has to be off as well. Once those two conditions are met, then the action is to turn on the switch. So if we just do call service, we can do switch.turnOn, and it will turn on the switch. And it will detect the switch when you set up this action. So once this is set up, you can go ahead and save it. And now we need to set up in automations the heat off. And it's going to look very similar to the heat on, so I'm not going to go into as much in detail. So we have the heat off here. Again, a time pattern one, so it's going to run every single minute. We're going to have two conditions again, but instead of -1, it's going to be +1, right? Because it's looking at the value we have in the box +1. Once it's higher than 1, we need to turn the smart switch off, which will kill the power to the heat mat. We also want to make sure that the switch is already on, because we don't want to run this command if the switch is already off, because we're turning off the switch. Lastly, we have our actions here. So we're going to call a service, switch, turn off a switch, and it will turn off this switch. So just to see this in practice, as you can see, I have this at 69 degrees. This is a live feed of my temperature of the iBlopper data that's coming in. And we also have this Inkbird just to show how the smart switch is working with the automation. So again, this is running every minute, and it constantly checks these two values to see if it wants to turn this on or off. So when we typed in 69 here, that the switch is going to be off until it hits 68 degrees. So still here it's too hot, it's too hot, it's too hot. And then once it hits 68 degrees, you notice directly above right here, it turns the switch on. So now that it's 68 degrees, it now turned the switch on. It's still on until it hits 70 degrees, because again, it's that value +1, and you can see right over here, you see the switch on to off. So once it hits 70 degrees, it turns the switch off. You'll see a little bit of a ramp up here. It's probably just from active fermentation, but the switch is off, and then you'll kind of see it start to drop again. And then eventually it will turn back on, it will turn back off. So this is kind of a cool way to see how this is working in real time. And again, this will update every single minute, because again, the automation runs every minute. So if you want to just change this to 65 or 90, you can go ahead and do that. And the automation logic will run, because it will constantly check this value against this value, and it will tell automation if we need to turn the Inkbird off or on. Really quickly, if you're interested to know how to get this tile on here to show the graph against the Inkbird switch, if you go to the top here, hit Edit Dashboard, hit Add Card, you're going to look for something called History Graph. Once you hit History Graph, you can go ahead and add your switch entity. So if we just type in switch, there's your switch entity. And then you also need to search for the temperature as well. So remember, we named that iBlopper temp. So that's iBlopper temp. If the iBlopper temp is not working, that's just because you may have not copied and pasted that section of code correctly into Studio Code Server. You do need this unit of measurement under the iBlopper temp. But that really about covers it, guys. Thanks so much for watching this video. I hope you guys learned something. I hope you guys found it interesting. If you stuck to the end of the video, I applaud you. Thanks so much for sticking around. If you like content like this, make sure to like the video and subscribe to my YouTube channel for more content like this. Anyway, guys, we'll see you in the next one. Thanks.